Good evening, Raghavendra, Samriddhi. Please confirm whether I'm audible. My voice is clear. Good evening, Bhumika. Bobby, Ayush, yes, I wanted to say this. Welcome back. Are you able to hear? Please confirm. Thank you, Samriddhi. Good evening, Sat Shri Akal, Sinchan. Rudra Kashish, very nice. And it's still 7-8 minutes remaining for the scheduled time. Thank you, Bobby. So till the point others are arriving, I wanted to ask this only. Apurv is saying quants mein dar lag raha hai. I was also thinking on same lines. I can see there are many things going on. Same topic is being repeated many times in live class, in practice session, in application class, otherwise also. So don't be confused. डरो मत. Bobby का बात सही है. Easy है. All is well. Nandini is also thinking I'm finding quant little tough. It's not tough. It's not tough. It's actually very, very easy. This is the basic tip, Rakesh. Don't be afraid of the things. See, numbers is a topic in quant in which there are many new things to learn. If you have not attended any of the previous class, certainly you should revise them whenever you get time. But don't worry. Today we are going to discuss something from the previous ones also and many new things also. Rimjim is saying quant is lovey or lovely, I mean to say. वत्सल आज जल्दी कहां से जल्दी भैया 7 का ही टाइम है ना. How many classes have been completed before this class in quant? भैया मैंने गिनी नहीं है. रिमाइंडर्स की आई थिंक आपकी दो क्लासेस मैंने ली हैं, उससे पहले भी एक हुई थी और उससे पहले भी हम नंबर्स की कुछ क्लास कर चुके हैं. तो आई होप आई थिंक 4-5 classes have been done at least. So you can check that in your event section. Is today completely new topic? It's not completely new. It's connected with the last one, but yes, many new things are there. LCM, HCF is new thing. Unit digit, last 2 digit, that is also sort of new thing, but they are connected. We will be connecting them with the previous part also. Good evening, Ramu. Lakshmi Shri is saying where to watch the videos of the previous week's classes. In the event section. In the event section, you are attending this live session in the event section of your Facebook group. So there only you can find all the links of the previous sessions also. Application classes are there and these live classes are also there. Ramu is saying I'm very excited today. LCM, HCF is enjoyable topics. Yes, certainly. Dina Thielen, sorry if I didn't pronounce it correctly. I have answered your query. Should we start solving IIM ABC? I do not know honestly what is the exact content of that, but certainly you must practice as much as possible. I have said this many times. Solve the questions as many as possible. Samprati is saying too much saturation brightness. Don't worry, abhi theek kar dete hain. I have not attended any class before. Should I watch them first? If you will watch them first, then you will be missing today's class also, Harsh. So it's better you go through today's class, attend this class, and then certainly you should go for the earlier ones also. But you can attend today's class now. Satyam is asking, do you recommend a book? There are n number of books in the market. There is no point in recommending any. But for practice purpose, see, one thing I would like to say, I have been saying this since many years while I was teaching, that for learning concepts, don't go anywhere else. Be here only. And for practicing questions, any material is welcome. But first step, whatever material you are getting from here, you should completely solve that first. Otherwise, there is no limit of solving material. You can go for that. But first, whatever material you are getting here, solve that first. If you have done that completely, then you are welcome. Then you are more than welcome to solve anything. Okay, I think we should start now. Video रुक कर चल रही है. अभिषेक रिफ्रेश कीजिए. Rolf is saying मेरा बेसिक बहुत कमजोर है. I read this statement somewhere. Strengthen your strength and weaken your weakness. So don't be afflicted, don't be affected by that कमजोरी. जो कमजोरी लग रहा है उससे affected मत हो, उसको improve करने की कोशिश करो. And you can do that. Okay, शुरू करते हैं. Yes, Rimjim, thank you. So it's almost 7 now, and others may join later. ठीक है. So today we are going to cover many new things. So one is last digits, find out karna, how to find last digit or basically unit digit of a number or last 2 digits of a number. I think you have done practice of these questions in your application class or practice sessions, but we will understand this first, how it is working. And the next part is LCM, HCF. So these are two broad topics which we are going to discuss today. And both these are connected with the topics which we have been doing earlier in previous classes, that is remainders. Okay? So in a way, that is a new topic as well as it is connected to the previous part also. Okay? So let's begin now. Okay, it is just restarting. Audio is fine. Yes, audible. So I've just restarted my system. The PowerPoint was hanged. Let's see why it is working. So hope it may take 1-2 minutes. So have patience. I just muted my audio so that I can see what's the issue. So these are the pros and cons of using technology, and it gets sometimes stuck. I think touch is not working here. Yes, he said, nice topic for VARs, the pros and cons of technology. What's the issue? Any technical person, how to make the touch screens touch work? I think touch is not working here. Open and close. I have just done that. फिर से try करें. Yes, touch is not working. Okay, let me again try. This time I'm ओके, ये नहीं चलेगा. So I hope now finally it will work. Yes. Fine. So let's start now. I'm sorry for this all delay. आज के लिए इतना काफी नहीं है कृष्णा. We are just starting. Yes, पढ़ाई शुरू करते हैं. So today's topics are the cyclicity of numbers and finding unit digit and tens digit. तो अब जल्दी से हम काम स्टार्ट करते हैं and no unnecessary talks in between. ठीक है? No unnecessary talks in between. So you can refresh your browser if there's any kind of issue. I hope sound is okay. Please confirm me. Sound is fine. Yes, ठीक, thank you. So this cyclicity is very important concept. अरे बाबा क्या There is some issue today. Okay, welcome back once again. So cyclicity of numbers and finding unit digit and tens digit. So this cyclicity is a very important term. You may have been hearing it repeatedly. आपने इसे पहले भी सुना होगा. But it is important to not only find the unit digit or tens digit, but many times remainders also can be found using cyclicity. What is the meaning of cyclicity? Meaning of cyclicity is that there is pattern of the things, whether it is unit digit or tens digit or remainders, which repeats after certain terms. क्या मतलब है? Let's say let's start with unit digit only. So 2 power 1. I'm first seeing the pattern of the unit digit. 2 power 1, it's a unit digit. Let me write it as UD, unit digit. So 2 power 1 is 2 only. Its unit digit is 2. ठीक है? हाँ, yes, never give up. And as I said earlier, please refrain from side talks now. Please focus here. So 2 power 1 is unit digit 2. 2 power 2, unit digit 4. 2 power 3 is 8 only, so unit digit 8. 2 power 4 is 16, right? So 16 means unit digit 6. Sound is okay? It must be there. Please confirm somebody in comments. Are you able to hear me? आ रहा है ना? हाँ, so those who are facing any difficulty, please refresh. All okay? Yes, please be here now. So 2 power 4 is 16. So 16 is having unit digit 6. See, our purpose right now is to focus only on the unit digit, and while I'm calculating unit digit, so I need to see only unit digit of the number. So this one is of not much importance. So if I want to find out unit digit of 2 power 5, what is going to happen? I just need to multiply this previous number by 1 more times 2. So if I double it, to just see the unit digit is 6, and when it is doubled, it will again end in 2, right? Although we know its value, but I'm focusing only on the unit digit. So it is again going to be 2. 6 multiplied by 2 is 2 again, as earlier. Now 2 multiplied by 2 again is 4. 4 multiplied by 2, again 8, 8 multiplied by 2 will end in again 6, and so on. So basically, whenever we are multiplying 2 in this previous value, we are getting the next number. 2 times 2, 4, 4 times 2 is 8, 8 times 2 ends in 6, and 6 times 2 again ends in 2. Isn't it? So basically what we can understand from here, that unit digit pattern is repeating after every 4 powers. 2 power 1, 2, 3, 4, and then again I reach to here 2 power 5, 6, 7, 8, again here 9, 10, 11, 12, and so on. So this kind of pattern, this kind of cyclicity we are going to find in many places. ठीक है ना? So that is the cyclicity of unit digit for the powers of 2. Yeah, cyclicity here is 4. See, now take one more example. If I ask you, what is the unit digit of 2 power 5? Now that's a small number, you can easily find out. 2 power 5, you know it is 32. So unit digit is 2. ठीक है ना? But if I ask you, what is the unit digit of, let's say, maybe 105? Now you don't know its value. 2 power 105. So how you can find the unit digit of this number? ठीक है ना? Now that's the question. 2 power 5 was a small number. You could have very easily found that this number is 32, so unit digit is 2. But number is 2 power 105. Now how to find unit digit? Now we are going to make use of this pattern which we have just seen. Let's revise what we have done. We have just found the unit digits of various powers of 2. So 2 power 1 was ending in 2, 2 power 2 was 4, then 4 times 2 is 8, 8 times 2 was 16, right? It was ending in 6. So 6 times 2, again, 6 times 2 is 12, isn't it? And which again ends in 2. So this pattern again starts repeating. So that's what we have discussed. So 2 power 1, 2, 3, 4, then 2 power 5 again has same digit, unit digit, 2 power 5, then 2 power 6, 2 power 7, and 2 power 8. So 2 power 8 will again end in 6. Like that, 2 power 9 again will come here, and so on. So from here, what we can understand, that powers of 2 are following this pattern or the cyclicity of 4 powers. After every 4 powers, unit digit repeats. ठीक है ना? So now we just need to see that this number 105, is it multiple of 4, or it is giving remainder 1 when divided by 4, 2, or 3, like that. So this 105 is of the form 2 raised to power 4k plus 1. ठीक है ना? You can easily check whether this number is divisible by 4 or not. How to check? You just need to see the last 2 digits. So this 105 is multiple of 4 plus 1, because 0, 5 when you divide by 4, 1 will be the remainder. So this number is of this form, 2 power 4k plus 1. So it will have unit digit same as that of 2 power 1, which is 2. So that is the right answer. ठीक है ना? Yes, application class में I have seen that you have done this. You have solved many questions like that. So just a quick revision we are doing. ठीक है? L and Y is 4k taken. So because this number 105 is multiple of 4 plus 1, and Y4, we are just seeing that there is cyclicity of 4. Unit digit is repeating after every 4th power. Unit digit is repeating after every 4th power. ठीक है ना? Yes, let's explain it again. Let's take some more examples. I'm erasing this, and unit digit of 2 की ही हम बात कर रहे हैं. अभी हमने देखा, I'm repeating the same thing. 2 power 1 unit digit was 2. So if I multiply this again with 2, that makes it 2 power 2. That was having unit digit of 4. I'm only writing unit digits. ठीक है? I'm only writing unit digits. I don't want to write the numbers again. So 2 power 3, that means again multiply with 2. So 4 into 2 is 8. And 8 into 2 will end in 6. That will have a unit digit of 6. So 2 power 4 is having unit digit 6. Now, after this, if I again multiply with 2, that is 2 power 5. So what will be the unit digit? 6 times 2, that is 12, which ends in 2. So 2 power 5 again ends in 2. Now further, when I will multiply one more 2, that is to make it 2 power 6, again it will end in 4. So that is the cyclicity of 4. After every 4th power, 2 power 7 will come here, 2 power 8 will come here. So here we are having powers which are multiple of 4, right? Here these are the powers which are 1 more than multiple of 4. This is 2 more than multiple of 4, and 3 more than multiple of 4. So in general, what we can say, so 2 raised to power 4k plus 1, a number of this form will have a unit digit of 2, right? Exactly same way numbers whose powers, who are of this form, 2 raised to power 4k plus 2. So they are having 4 as the remainder, 4 as the unit digit, 4k plus 3 have a unit digit of 2 power 3, that is 8, and then numbers which are of this form, 2 raised to power 4k, will have 6 as unit digit. ठीक है ना? And this pattern of unit digits which we have seen for powers of 2, it works for basically all the digits. हम जल्दी से इसको भी करते हैं. And let's apply this in some questions. Those of you who have done it already earlier, answer this question now. What is the unit digit of 2 raised to power 2024? What is the unit digit? Please write your answer fast. 2 raised to power 2024. What will be the unit digit? Yes, that's correct. So most of you are writing 6, but in between I can see some other numbers also. It is going to be 6. How to check? See, now first step, those who are having a little bit doubt, see here. So what is the first step? I need to see this power. So this power, I need to check whether this is multiple of 4, that is 4k, or it is giving some remainder 1 or 2 or 3 when divided by 4. ठीक है? I just need to confirm कि this power is of what form when divided by 4. So the first step would be to divide this number 2024 with 4 and see whether it gives a remainder 0 or 1 or 2 or 3. So when you divide it by 4, what is the remainder? So dividing by 4 is very easy. We just need to see the last 2 digits, which is 24, and 24 is divisible by 4. That means this number is divisible by 4, right? So this number is of the form 2 raised to power 4k. Fine. And now whenever power is multiple of 4, the unit digit is going to be same as that of 2 power 4, which is 6. So this unit digit is going to be same as that of 2 power 4, which is 6. So we don't need to remember these values, that we can calculate very easily. What we need to see is that only, that the power is of what form, 4k plus 1, 2, 3 or 4k. Fine. One more question. Any doubt here? No. Let me ask you one more question based on this only. I'm writing the number here. If the number is 2 raised to power, say, क्या लिखें? 2 raised to power 2025. Now, this is the number. 2 raised to power 2025. Find the unit digit. Yes, I'm repeating only, don't worry. These are different examples for that purpose only, so that it can become clear. Now this is the number, you have to find the unit digit. 2 raised to power 2025. What will be the unit digit? Now here's one new thing which very easily, in which you can commit mistakes. So this is a number raised to power raised to power. Right? So there are two powers. It's also called power tower. So 2, 4, these are different answers. Let me tell you, all these answers are wrong. See, 2, 4, 8, 6, these are the only possible values. Hai na? So if you are randomly taking any value, randomly putting any value, so that is not going to be sure. So most of you are writing 4, which is not correct. Satyajit, Pradeep, Ashmit, some of you are saying 6, some are saying 8 also. 4 is not correct. 6 is the right answer. Now see, let's repeat, those who are having confusion in the doubts. Last 2 digits of the power, not required. ठीक बात है, that was the right point कि last 2 digits of the power निकालना होगा, but that's not required. That's not required. See, a power m raised to power n का formula लगा सकते हैं. No Gayatri, a power m raised to power n is different thing. Now see the difference. First see the difference in two things. There are two kind of things in powers. First understand the difference. After that we will go to this question. If I give you 2 raised to power 3 whole power 4, that's one number, and another number is 2 power 3 power 4. Let's say call this number as a and this number b. Are these two numbers a and b equal or different? First tell me that. These two numbers a and b, are they same or different? They are different numbers. They are not same numbers. Yes, they are not same numbers. So while dealing with the numbers of this format, whether this one or this one, so don't get confused. They are different numbers. This number, when written in the form of power of 2 only. So what is the power of 2 here? It is 3 multiplied with 4. That is 12. ठीक है ना? This is 2 raised to power 12. And what about this number? This is 2 raised to power how much? The second number, this b. This is 2 raised to power how much? Yes, it is 81. This is 3 power 4. This is 3 power 4. This is 81. So when we are doing whole power 4, that is different thing. And when this power 4 is only raised to power 3, it is 3 raised to power 4. This is 81. So 2 power 12 and 2 power 81, certainly they are not same numbers. They are different. Okay? The same way, don't do this mistake here. It is not 2 square whole power 2025. No. So here, power of this base number is 2 raised to power 2025. Isn't it? So this 2 is a base number. And we know that it's a unit digit repeats after every 4th power. So that's the cyclicity of 4 here for the unit digit. So now 2 raised to power 2025, that we need to think. Okay, here in between Nandini is asking how 81. Bhai 3 raised to power 4 kitna hota hai Nandini? 3 raised to power 4. Can you calculate this value? 3 raised to power 4 basically means 3 multiplied with 3 multiplied with 3 multiplied with 3. Isn't it? That's 81. तो फिर यहाँ पर 81 क्यों नहीं हुआ? यहाँ 81 क्यों नहीं हुआ? Try to understand. This is very basic thing, but very important. Most of the students commit mistake here. यहाँ पर 81 क्यों नहीं हुआ? यहाँ पर 3 into 4 क्यों किया है? Why we have multiplied here to make it 12? So because this 4 power is to this bracketed number 2 power 3. So this bracketed term, let me write here, is 2 power 3 raised to power 4. Actually it means this 2 power 3, this term is multiplied 4 times. Again multiplied with 2 power 3, again multiplied with 2 power 3 and 2 power 3. Right? So this is 2 power 3 and 3 more and 3 more and 3 more. That makes it 2 power 12. Because in each bracket we are having 3 2's. So 2 into 2 into 2, again 2 into 2 into 2, again 2 into 2 into 2, like that. So total 12 2's are there. So this is 2 raised to power 12. And that was 2 raised to power 81. ठीक है ना? Yes, exactly. Bracket का खेल है सारा. बिल्कुल सही बात है अमन. Okay, coming back here. Now this is 2 raised to power 2025. I don't need to calculate its value. That's not required. That's not required to calculate its value. So I just need to find out whether this number is divisible by 4 or it gives some remainder. Tony is asking, can you explain 2 power 2024 again? 2024. This 24 was the first step. बेटा वही तो बात कर रहे हैं. तभी तो अगला सवाल लिया है. Why you are going back? No need to go back. See here. हाँ, Don't go here and there. जो मैं बात कर रहा हूँ, please remain there only. See, these examples we are taking so that we can understand the concept clearly. So we have seen so far that 2 raised to power anything it is, so that power is going to be of the form 4k plus 1, 2, 3 or multiple of 4, right? And only these are the different terms where we are going to get different unit digits. So we just need to see whatever is the power given, 2 raised to power, whatever is the power, I need to find out whether that power is divisible by 4 as was the case with 2024. So in that case, this power is multiple of 4. So unit digit will be same as that of 2 power 4. This is the reason, right? Now this is the second question. Here 2 raised to power, this is the number now, this is the power. So I need to find out when 2 raised to power 2025 is divided by 4, what will be the remainder? Many of you are writing 1. 1 is a wrong answer. 1 is the wrong answer. It's not of the form 4k plus 1. 2 power 2025. Shashank, please tell me. Yes, remainder 0. Harsh, Sagar, that's correct. Vivek, that's correct. This is multiple of 4, Baba. This is divisible by 4. अरे 2 की power 1 से ज़्यादा होते ही that number becomes divisible by 4. Isn't it? This 2 power 2025. ये मैंने जानबूझ के odd लिखा है. Sometimes you know student thinks अगर 2 power 2024 होता तो divisible है, but 2 power 2025 is not. It is divisible. ठीक है? So this power is multiple of 4. So this is basically 2 power 4k. And which means unit digit will be same as that of 2 power 4, which is 6. ठीक है? हाँ, good question. Rakesh is asking how multiple of 4? How multiple of 4? Let me erase this part. So we have understood so far the cyclicity part. Now how to apply this? Let's understand this. So 2. So number was 2 raised to power 2025. We have seen that unit digit repeats after every fourth power. So I need to check whether this power is multiple of 4 or of what form, that I need to see. So I need to find second step, that what is the remainder when this number is divided by 4. So 2 raised to power 2025 mod 4. So some of you were writing 0, some of you were saying 2, some of you were saying 1 also. But dear students, 2 raised to power 2025 is completely divisible by 4. अरे बाबा 4 का मतलब 2 into 2 ना, and this is having 2025 2s. 2 multiplied with 2 multiplied with 2 and so on. How many times? 2025 times. तो अगर इसको 2 into 2 यानी कि 4 से डिवाइड करना है, इज इट डिविजिबल और नॉट? इज इट डिविजिबल और नॉट? हाँ गुंजन 2025 का क्या करना है? मुझे तो ये पूरा पावर देखना है ना. I am not dividing 2025. I am dividing this power of base number. My base number is this 2 and power is 2 raised to power 2025. So don't get confused in this. ठीक है ना? That is a very basic thing and mostly many students commit mistake. I am seeing that this is not the first time. For last more than 20 years I am saying very easily लोग इसमें गलती करते हैं. अरे we are looking at cyclicity only, Sarvesh. Cyclicity of 4 के लिए 4 से remainder check करना होगा ना. That's what we are doing. So this power is multiple of 4. That was the point here. Is it clear? There were many confusing doubts. I think Gayatri and many others were saying. Yes, good. You got it. Nice. So this number 2 raised to power 2025 is divisible by 4. ठीक है? So now this power is multiple of 4. That means our actual number is of the form 2 raised to power 4k. Right? That was the step of the cyclicity. So this will have same unit digit as that of 2 power 4, which is 6. ठीक है? आई एम गिविंग मोर एग्जांपल, जल्दी से सॉल्व करके बताना. इफ नंबर इज लेट्स से सी वन थिंग, द साइक्लिसिटी जो भी हमने 2 में चेक की है, इट विल वर्क फॉर ऑल द अदर नंबर्स आल्सो. सो आई एम चेंजिंग द नंबर नाउ. लेट्स से माय नंबर इज मे बी 3. नाउ पावर ऑफ 3 वी आर टॉकिंग अबाउट 3 raised to power 4. फर्स्ट टेल मी व्हाट विल बी द यूनिट digit of this number 3 raised to power 4. You can calculate on your own. 3 power 4, that's a simple number. 3 power 4, what will be the unit digit? It's 1. As I said earlier, cyclicity of 4 works for all the digits. Some digits repeat before that also, but in general we take it to be 4 only. So for 3 we can check very fast. 3 power 1, 3 power 4k plus 1 will end in 1. That is 3 power 1 ends in 1. 3 power 2 will end in 9, right? Again if I multiply with 3, 3 power 3 will end in 7. 9 3s are 27, that ends in 7, right? And 7 को फिर से 3 से multiply करूंगा, 7 3s as 21, that ends in 3 ones are 3 right, sorry, 1. ठीक है? Let me check it again. 3 power 1 was 3 only. If I multiply one more 3, that is 3 square, that ends in 9. So 9 into 3 again ends in 7. 7 into 3 ends in 1. Right? This is 3 power 4. So if it is 3 power 5, that means if I multiply one more 3, so 1 into 3 will again end in 3 and again the cycle will repeat. So as we had seen in the powers of 2, same happens with the power of 3 as well. ठीक है ना? So there is cyclicity of 4 in general for all the numbers. Now 3 power 4 unit digit 1. ठीक है ना? Now tell me what will be the unit digit if the number is 3 power 41. Please answer fast. 3 power 41, you have to find the unit digit. Yes, 3 is the right answer. So what are the steps? So please see here again. So I need to see the power. I need to see whether this power is divisible by 4 or of what form. Means what is the remainder when this power is divided by 4. Now 41 is a simple number. So this is 3 raised to power 4k plus 1, right? 41 will give remainder 1 when divided by 4. So 41 is of the form 4k plus 1. So its unit digit will be same as that of 3 power 1, which is obviously 3. So this is the right answer. ठीक है? Sampriti, you can refresh, I guess. If we divide 2024 by 4, then also answer will be same. गलत करके भी आंसर सही आ जाता है. Don't do that. I said this earlier also, I guess. And see, that happens in numbers many times. If we apply the wrong method, then also sometimes you may get the right answer, but it not always. So don't do that. So apply the correct steps. That's why we are repeating. Okay, let's take more example now. Tell me what will be the unit digit of 3 raised to power, say क्या लें? 4 कर दे? 4. चलिए 3 raised to power 4. Find the unit digit. Now this is the number 3 raised to power 4. Oh, now Kusum says 3, Aniket says 1. One or 3, there are two different answers. 1 or 3. See, 1 would have been there if the power is multiple of 4, but this 3 power 4 is not multiple of 4. So first step is to identify that this 3 is my base number and this 3 power 4 is the power, right? This 3 power 4 is the power. So 3 power 4 is 81. Yes, that's correct. Thank you, Vedanti. So this 3 power 4 is 81. So 81 is 4k plus 1. So this number is of the form 3 power 4k plus 1 as the previous case. So that's perfectly fine. So unit digit will be same as that of 3 power 1, which is 3. ठीक है ना? So that's the basic thing. I hope all of you can do it now. ठीक है, let's take 2-3 more examples. सर 4k वाला कॉन्सेप्ट फिर से एक्सप्लेन कर दीजिए प्लीज, समझ नहीं आया आदित्य सिंह. सो आदित्य जी, हमने ये बात की है दैट यूनिट डिजिट रिपीट्स आफ्टर एवरी फोर्थ पावर. लेट्स वेरीफाई इट. यस, आई एम रिपीटिंग ऑल द थिंग्स सो एज टू कवर ऑल द डिजिट्स. ओके, see powers of 2 we have seen. I'm writing it here. So 2 So 2 power 1 ends in 2, right? 2 power 2 ends in 4, 2 power 3 ends in 8, and 2 power 4 ends in 6, and 6 when again multiplied by 2, the same cycle repeat, right? So 4k plus 1, 4k plus 2, 4k plus 3, and 4k. ये 4k क्यों आया? Because it is repeating after every fourth power. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on, right? So every 4k, every power which is multiple of 4 is coming here, and every power which is 1 more than multiple of 4 is coming here. So that's why we have written 4k plus 1, 4k plus 2, 4k plus 3, and 4k, right? Let's check for the power of 3, which we just did. So for 3, so 3 power 1 ends in 3, 3 power 2 will end in 9, 3 power 3, when again this 9 is multiplied with 3, it will end in 7, and when this 7 is again multiplied with 3, that is 3 power 4, that ends in 1, ठीक है ना? अभी हमने लिखा था. And when this 1 is again multiplied with 3, so again 5th power will go here, 5th power, 6th power, 7th power, 8th power, 9th, 10th, 11th, 12th. So all powers which are multiple of 4, that gives you unit digit 1, and which is 1 more than that, 4k plus 1, that gives you unit digit 3, 4k plus 2 will give you 9, and 4k plus 3 powers will give you 7. So same cyclicity. Yes, that's called cyclicity. This is basically pattern. This pattern is repeating. That's what is called cyclicity. It is repeating after every fourth power. Okay, same thing happens with powers of 7 and 8 as well. Let's check for 7. 7 power 1 ends in 7. ठीक है ना? 7 power 1 ends in 7. 7 power 2. If I again multiply it with 7, so 7 into 7 is 49. So it ends in 9. ठीक है? 9 को फिर से 7 से मल्टीप्लाई करेंगे, 7 क्यूब, तो 9 into 7 will end in 3, and 3 into 7, that is 7 power 4, will end in 1, and 1 when again multiplied with 7, it will again go here, right? So first power, second, third, fourth, and again 5th power will go here, 5th, 6th, 7th, 8th, same thing. So again 4k plus 1, 4k plus 2, 4k plus 3, and 4k, because every multiple of 4, whenever power is multiple of 4, we are getting unit digit 1, and whenever it is more, 1 more than multiple of 4, again 7, and then 9, and 3, and 1. That is cyclicity. Same thing happens with powers of 8 as well. So 8 power 1 ends in 8. ठीक है, 8 ones are 8, and 8 square if I am going to do 8 into 8, that will end in 4, right? 8 into 8 is 64, you know that, so it ends in 4. 4 को फिर से 8 से multiply करोगे, 4 into 8 will end in 2, right? So that will be the unit digit here, and 2 again when multiplied with 8, that is 8 power 4, so 2 into 8 ends in 6. ठीक है? Now when the 6 is again multiplied with 8, so 6 into 8 again ends in 8, so that means 5th power again go here. So 5th power, 6th, 7th, and 8th. So again, all powers which are multiple of 4, they will give you the unit digit 6 now. And whenever it is 1 more than multiple of 4, so we are going to get this 8, and 4k plus 2 will give you this power, this unit digit, and like that. So that's how for 2, 3, 7, 8, we can see that after every fourth power, a unit digit pattern repeats. ठीक है? So other than this 2, 3, 7, 8, we are having two digits 4 and 9. Which repeats after every fourth power, that's 2, but they repeat prior to that also. They repeat after every 2 powers basically. 4 power 1 ends in 4, ठीक है ना? And 4 का square करोगे तो it is 16, that ends in 6. And 4 cube if I do, so 6 into 4 again ends in 4. And again 4 into 4 again ends in 6. So basically it repeats after only 2 powers, every 2 powers. So for odd powers we can say it ends in 4 and for even powers end in 6. See, अब ये दो powers के बाद repeat कर रहा है, so can we say that it is repeating, it will repeat after fourth power also? Yes, certainly. So in general we consider the cyclicity for unit digit as 4. After every fourth power तो हर केस में repeat होना ही है, but यहाँ पे उससे पहले भी हो रहा है. So same way 9 you have written, that's perfectly fine. So 9 power 1 will end in 9 and when this is again multiplied with 9 it ends in 1. 9 into 9 is 81, that ends in 1. ठीक है? And अब उसके बाद there are 4 digits, that is 0, 1, 5 and 6. They are such special numbers. When they are raised to any natural number power, they always end in same digit. 6 raised to any natural number power always have a unit digit of 6. Same way 5 when raised to any natural number power always ends in 5. Same way 1 when raised to any natural number power it always ends in 1 and same is with 0. So that is the whole thing of unit digits, right? So in nutshell, as I said earlier also, the cyclicity of unit digit is taken to be 4. After every fourth power, unit digit is certainly going to repeat. ठीक है? And as I said earlier, you have practiced many questions in your practice sessions, application classes also. Okay, let's move further now. So I hope there should not be any doubt in this basic part, and we can do 1-2 more questions to clarify it more. Okay, here is one thing. So many natural numbers, particularly 4k. I missed your comment. Lakshmi Narayan says, can we write 2k plus 1 for 4? Yes, Lakshmi Narayan, we can do that, but that's not required. Don't burden your head. Don't burden. But what you have said is perfectly fine. Priyanshu, I missed the comment. समझ में आ गया है. Good. It means cyclicity is 1 for 0156. Yes, Siddharth, that's true. For 0156, we can say cyclicity is 1. But in general, ये every 1 power के बाद repeat हो रहा है. यहाँ पर unit digit after 2 powers के बाद repeat हो रहा है. And in these cases, unit digit is repeating after every 4th power. So in general, 4th power के बाद तो सभी में repeat हो ही रहा है. That's why I said कि unit digit in general is taken as having a cyclicity of 4. Okay, let's move further. So we have having some questions now. So before we go to the tens digit part, that we'll do later. But this concept of cyclicity is also used in the remainders. See here, question is find the remainder when this number is divided by 6. Please do it on your own. After that, you'll understand the cyclicity here. First, try to answer this. Here's one question. Shweta is asking 3 power 2025. ठीक है श्वेता, मैं इसको लिख लेता हूँ. We have talked about this. We will discuss it again. Don't worry. We have to find unit digit here, right? ठीक है. First, answer this question. हाँ, 2 digits उसके बाद करेंगे. अभिषेक, wait. First, यहाँ तक रखो. Try to answer this question now. Find the remainder. What is the remainder when this number is divided by 6? Priyanshu says we can take the value of k to understand the table more easily. Table को remember करना ही नहीं है Priyanshu. We were to just see that power is of what form, 4k plus 1, 4k plus 2 like that, and then we can directly write the value. Okay, many of you are saying the remainder for this number is 6. Okay. In between I am saying 3, 4, 6. Oh, you are getting different answers. अरे तो आसान सवाल है. 6 से remainder निकालना है. Some are saying 6, some are saying 3. Okay, that's enough time. Can somebody write how you are getting 6 or how you are getting 3? Because many of you are writing 3 or 6. वंशिका ने 9 भी लिख दिया. भाई 6 से डिवाइड करने पे 9 रिमाइंडर नहीं आता. Which method you are going to use here? सही बात, अगर 6 रिमाइंडर आया होता तो 6 से डिविजिबल होता ना. 6 रिमाइंडर आ कैसे सकता है? बिल्कुल अच्छी बात बोली आपने. Yes, using CRT, Shriti is saying. Sarvesh ji unit digit पे है फिर से 2 4 power 2025. Sarvesh, keep it there. We will talk about. We have written one example. We will cover it again. Don't worry. अरे ये 6 से ज्यादा रिमाइंडर कैसे आ रहा है? Some of you are writing 9, 7. दीक्षा भाई 6 से डिवाइड करने पे 7 कैसे रिमाइंडर आ सकता है? Remainder will be certainly less than 6. And 6 cannot be the answer, as many of you were saying by the valid comment कि अगर 6 रिमाइंडर होता तो वो तो डिविजिबल हो जाएगा ना. 3 is the right answer. 3 से डिविजिबल है, 2 बच जाएगा. Excellent. See, 6 equals to 3 into 2. As somebody said that using CRT. So yes, we can break this divisor into two divisors, two factors which are co-prime 3 and 2. So 3 से तो ये number divisible है ना? This number is divisible by 3. So remainder is going to be multiple of 3. And 2 से when I divide this number, remainder is 1. Right? When this number is divided by 2, remainder is 1. Is it not? So we just need to club them basically. We just need to club them. So or we can use, we can make equation or we can work with numbers only. Let's work with numbers. So 3 से remainder 0 देने वाला, smallest number 0, and the next number will be 3. Next number will be 6. Next 9 and so on. There are many numbers, right? Now I need to find out the smallest number which satisfies this condition. That means 2 से divide करने पे 1 remainder दे. Will 0 satisfy? No. Will 3 satisfy? When divided by 2 it leaves remainder 1. Yes, it works. आगे जाने की जरूरत ही नहीं है. So this is our answer. Using CRT was one of the ways, and yes, we can make equation or we can combine numbers like this. ठीक है. ऐड का पूछ रहे हैं, प्लीज शो CRT for 2. उसमें शो क्या करूं भाई? दिस नंबर 2 से रिमाइंडर 1 आएगा ना. दिस 9 इज एन ऑड नंबर. 9 को जब आप 2 से डिवाइड करोगे, रिमाइंडर इज 1. 1 रेज टू एनी पावर इट मे बी, इट इज गोइंग टू बी 1 ओनली. हाँ अनुराग करा रहे हैं, साइक्लिसिटी करा रहे हैं. वेट. देवांशु एक्सप्लेन वंस अगेन. क्या एक्सप्लेन करूं बेटा? विच थिंग इज नॉट क्लियर? See, some of you said that using CRT you have solved it. Very fine. So using CRT, 6 means 3 into 2. We need to break this divisor into its co-prime factors, which is 3 into 2. And 3 से ये number divisible है because 9 the base number is divisible by 3. So this entire number is divisible by 3. So remainder with 3 is 0. And when I divide this number by 2, I get the remainder 1. कैसे पता लगा? This is an odd number. So this 9 when divided by 2 leaves remainder 1. And now 1 raised to any power is giving remainder 1. So now we just need to club them. You can make equation as I think somebody wrote in the comments. So you can say 3x equals to 2y plus 1. You can satisfy which value will satisfy. So if you put x equal to 1, that makes it 3. And if you put y equals to 1, that also makes it 3. So 3 is the combined value. So you can make equation to find out the values, or you can directly work with the numbers. Look for those numbers which satisfy both the conditions. So basically 3 is the remainder for this question. Okay? Now how we can use cyclicity here, that is the question here. Okay? How we can use cyclicity. Now understand, this is bracket, this is 9 power 33 whole power 33. Okay, na? So this number can be written like this, 9 power 33 whole power 33, which means if I convert this 9 as in the power of 3, I can write it, or let it be 9 only. What's the issue? So this is basically 9 raised to power 33 multiplied with 33. ठीक है ना? So in 9 की कोई बहुत बड़ी सारी पावर है. We want to find the remainder when this is divided by 6. So cyclicity का यहाँ पे क्या मीनिंग है? As I said, cyclicity means pattern. There is a repetition of pattern. So remainders में भी ऐसा होगा. ये 9 की इतनी बड़ी पावर होने की बजाय अगर 9 की पावर 1 ही होता तो, if it had been only 9 power 1, so we are checking remainder with 6. That is mod 6. ठीक है? So when we divide 9 power 1 with 6, what will be the remainder? It's easy to calculate. If you divide 9 by 6, remainder is 3. Is it fine? ठीक है ना? Now if I multiply with one more 9, that is 9 square. So now what is going to be the remainder? So 9 square means 9 into 9. Each 9 was giving remainder 3. So 3 into 3 is again 9. That is again 3. 9 square also gives remainder 3. Is it right or not? Although this is small number, you can directly find the value also. 9 square is 81. 81 को 6 से divide करोगे तो 3 is going to be the remainder, right? And if it had been 9 cube, then again same thing. It is going to be 3. 9 power 4 again 3. So basically whatever be the power of 9, always we are getting remainder 3 when divided by 6. So there was no need of using any CRT or something. So we could have seen what is the pattern. Okay? So 3 is the answer here. Is it fine? Now see the important point here. In this case, it's just by chance that at every power we are getting the same remainder. It is not necessary in every case. But there will be pattern always. It may happen that 9 power 1 is giving some remainder, 9 power 2 is giving some other remainder, then 9 power 3 is again giving the remainder as the earlier one. So there will be pattern always. So pattern repeats after every term, every power, or every 2 powers, or every 3 powers. That may vary. But pattern will always be there. So that is the key idea to discuss about this idea of cyclicity. Okay? Shweta is asking why always 3? Bhaiya, 3 aa gaya. We have just found the values and it is coming out to be 3. So why we are checking this? Our idea was that there will be a pattern. So what is that pattern? To identify that, we are checking the small powers of 9, what remainder we are getting. And in this case, we have just found that at every power of 9, we are getting remainder 3. How did we calculate? 9 power 1 to आसान ही है ना, 9 को 6 से divide करोगे, remainder is going to be 3. So for 9 square, what I did, I'm telling you, I calculated like this. 9 square is 9 into 9. Okay? Now 9 was giving remainder 3, so here remainder is 3, here remainder is 3, so 3 into 3 9, and 9 is giving remainder 3. That is one of the ways. And although this number is small, so you can directly calculate also. 9 square 81. So 81 को 6 से divide करोगे, so 78 is divisible, 3 is the remainder. Right? And again when you multiply 9, you can continue like this. Okay? So that is the idea how to use cyclicity, the concept of cyclicity in calculating the remainders when there is a large power. Okay? Let's move further now. Yes, Ishani, wonderful thing. Is it related to the fact that cyclicity of 6 is 1 and that's why remainder is 1? Yes, wonderful. That's the idea. बिल्कुल सही बोल रहे आपने. But don't mix it. Do it like this only. But the reason is that only. Reason is on the similar lines, not exactly same, but on that lines only. ठीक है, हम आगे बढ़ते हैं. Here's one more question. What is the remainder when 3 power 45 is divided by 5? You have all the ways to do. Now see how to solve it. 3 power 45 divided by 5. Please answer. Ramu, your question 17 power 17 power 17. I think not required at this level, but I kept it in my mind. I will see if we will be able to discuss it today. So 3 power 45 divided by 5. So many of you are saying 3. In between I see Webhow writes 1. Yes, okay, many of you writing the correct answers. In between I'm getting the wrong answers as well. But tell me, how have you solved it now? What's the easiest method? Yes, Euler. We can use Euler or format, basically the same thing. That's wrong. Somebody wrote unit digit will be इतना, तो answer will be इतना. नहीं, unit digit से answer नहीं आएगा. Unit digit से answer आ जाएगा क्या? हाँ, आ जाएगा ना वैसे तो. आ जाएगा भाई, सही है. Good, that's a nice idea. Okay, right, Euler is one of the ways. So first thing which comes into mind is of course Euler's, because we have discussed about it for last many classes. So 5 and 3, they are co-prime numbers, so we can apply Euler's theorem. Now Euler number for 5 is 4. So whenever there is 4th power or any multiple of 4th power, the remainder will be 1. So this 3 power 45 is basically 3 power 44 multiplied with 3 power 1. Now this power is multiple of 4, so that will give remainder 1, so our final remainder is 3. So that is the method of Euler's. Wonderful. Now in between I saw a very nice comment here. Let's find its a unit digit. See, how to find remainder with 5? We know that a number is said to be divisible by 5 depending upon its unit digit only, because other than unit digit, everything else is divisible. So we just need to see the unit digit. So one of you wrote in the comments, that is a very nice thing. So if I find its a unit digit, can you calculate its unit digit? So unit digits follow the pattern of 4. Again, this power is 4k plus 1. So this 3 power 45 is of the form 3 raised to power 4k plus 1. So it will have a unit digit same as that of 3 power 1, which is 3. So now this is a large number ending in 3. So when divided by 5, the remainder is going to be 3. ठीक है ना? Whenever we are dividing a number, let's say there is a number A, B, C, 3. Let's say this is a 4-digit number. What will be the remainder when this 4-digit number is divided by 5? What will be the remainder? Of course, it is going to be 3. ठीक है ना? That is also a very nice thing here we can find. But yeah, and the other thing which we discussed in the last question, as it is a large power, we can find out the pattern actually. So by checking remainder of various powers of 3 mod 5. So if I'm dividing with 5, all the different powers of 3, let's check out 3 power 1 when divided by 5, remainder is 3. ठीक है ना? I'm using the same pattern as we did in the last question. हाँ, मैं वही बात कर रहा हूँ अभी. Singh Aishani is asking, last question can also be solved in the same way. In that case, Aishani, we were to find the remainder with 6. And to find the remainder with 6, we don't see that last digit only. That's why that could not be applied there. Okay? So don't get confused. So now we are using the pattern of remainders. So 3 power 1 when divided by 5 gives remainder 3. Can you tell 3 square को अगर 5 से divide करेंगे तो क्या remainder आएगा? It's 4, right? And 3 power 3 को, that means again multiply 1 more 3, 4 into 3, 12. 12 when divided by 5 gives remainder 2. And 3 power 4 को again multiply with 3, 2 into 2, 3 is 6. 6 when divided by 5 gives remainder 1. We have found one. Wonderful. इसके बाद फिर से 3 power 5 पे जाऊंगा तो वहीं पे आने वाला हूं, right? So this pattern of remainders repeat after every fourth power, which we knew from the Euler's method also. ठीक है ना? So that's it. The same process follows and we get our answer. So 44th power यहाँ पे आ जाएगा and 45th will come here. So 3 is the answer. Right? So I hope we have discussed the various ways with all these examples. Abhishek is saying explain again by unit digit method. That is not a method, Abhishek. To find remainder with 5, we need to check only last digit of the number. That's why it was applicable here, not in every number, not in every case. Okay? That is not a method. That's why in the beginning I said this is not correct, but when I realized that it is asking remainder with 5, then I corrected myself that it is valid here. ठीक है, आगे बढ़ते हैं. We have to cover lot more things. Don't worry. So बीच में मैंने एक क्वेश्चन छोड़ दिया था, मैंने कुछ लिखा था यूनिट डिजिट का, but that will be covered here now. Please find the unit digit of 7 power 3 power 4n. Find the unit digit. Here n is a positive integer. Yes, Abhishek, not in every case. Bablu is saying one more example with big numbers. We will do that later. Right now, do this. रामू बड़े-बड़े नंबर ही लेकर आएंगे. भैया बड़े-बड़े नंबर छोड़ दीजिए अभी. रामू, not for now at least. Find the unit digit of this number. 7 raised to power 3 raised to power 4n. I want same answer. Don't give me different answers. I know that there are exactly 4 possible values. No, 1, 3, 7 or 9. Give me one answer. Shahruddin, yes, we are going slowly and we are repeating the same thing again and again so that you can understand properly. Okay, I am seeing all correct answers on my screen now except Akshay. Akshay, how 8 भाई? 7 की पावर का 8 कैसे यूनिट जा सकता है भाई? I think this was some typing error. 7 is the right answer and most of you are writing it correctly, so I hope that this point is home. You have understood this? Let me repeat again. So 7 power 3 power 4 power n. So 7 is my base number. 7 is my base number and the power is 3 raised to power 4n. Right? So our first step is always check this power when divided by 4. So 3 power 4n mod 4. What is the remainder when this power is divided by 4? That's what we need to check, right? Now it is very easy how to find remainder with 4. So this 3 when divided by 4, if I use a negative remainder, it gives me remainder minus 1 and minus 1 raised to power 4n. It is going to be certainly plus 1, isn't it? That means this power when divided by 4 gives remainder 1, or I can say that this power is of the form 4k plus 1, right? So this number will have same unit digit as that of 7 power 1, which is 7. So sometimes some of the students leave the question at 1 only. If 1 aa gaya, to bas 1 is the answer. No, that's not correct. So 1 is the remainder when this power is divided by 4. It only tells me that power is of the form 4k plus 1. Now unit digit will be same as that of 7 power 1, which is 7. So this is the right answer. ठीक है, this part is done. Yes, it is mode 10 also. That's right, Tanmay. To identify n, we should mode with 4. Not to identify n. I need to always find out whatever is the power. So I need to find out the power is of the form 4k plus 1 or 2 or 3 or 4k. Right? That was the objective. ठीक है, हम आगे बढ़ते हैं. Here's one more question. Find the unit digit of 44 raised to power 66. Please do it fast. Kamlesh, which step you want me to repeat? Noor is asking how 3 power 4k is 4k plus 1. Okay. I wrote all the things in the previous questions also. Let's see in this question now. It will become more clear. 44 raised to power 66. We want to find a unit digit. Some of you are writing. Rimsha is saying 4. Narayan is saying 4. Others are saying 6. Bhumika 64. 64 कैसे आया? 6. Okay. Most of you are saying 6. See, we just saw 2-3 slides back that power of 4 repeats its unit digit after every 2 powers, right? Remember, 4 power, whenever it is odd power, it ends in 4. And for even powers, it ends in 6. This is even power here, right? So it's done. Nothing to be written. This 6 is the right answer. ठीक है ना? Or if I'm considering cyclicity of 4 only, that's also no problem. So this is 4 raised to power 66. See, 44, this 10th digit is of no use. I only need to see the unit digit, so I just can take it as 4 raised to power 66. ठीक है? I need to find the unit digit ना, so 44 is not required. Only 4 is sufficient. ठीक है ना? अरे बाबा. Okay. ठीक है? Answer this one first. 23 multiplied with 42 multiplied with 17. What will be the last digit of this number? Please answer fast. What will be unit digit of this product? Everyone. What will be unit digit of this product? How to calculate that? Are you multiplying the complete numbers? Those who are having doubt in 44 and 4, please tell me, how will you calculate this value? How will you find the unit digit? Yes, we will take only the unit digit. Thank you, Astha. Yes, Joy, only last digit. That's what I was doing here also. See, this was only 2 digit number. If I asked you, what will be the unit digit of 2345 multiplied with 5198, what will be the unit digit of this product? Now, these are 2 4 digit numbers. What will be unit digit of this product? Yes, Tejinder, that was right. Yes, it is going to be 0. I don't need to multiply these large numbers. While calculating the unit digit, just check your multiplication process. To find the unit digit, you multiply this unit digit with this unit digit of the other number, right? So their product is going to give me the unit digit of the final answer. So now 8 into 5 ends in 0. That is my unit digit. None. Same way here, 7 multiplied with 2, that is going to give me unit digit of 4, right? Now this 4, when multiplied with 3, that is going to give me unit digit of 2. So that is my answer here. So while working on unit digits, we are concerned only about the unit digit of the base numbers, right? Base number का unit digit ही देखना है. So this is basically 4 raised to power 66. Fine. Now, if I'm considering cyclicity of 4 only, I don't remember this. I forgot this. Don't worry, no problem. So I need to write the 66 as what will be the remainder with 4. So if I divide 66 by 4, remainder is going to be 2, right? So this is basically 4 raised to power 4k plus 2 because 64 is divisible. 2 is the remainder. Now unit digit will be same as that of 4 power 2, which is 6. So that was the process which we have done in all the previous questions also. So those who are having any doubt in any type of thing, so these are the different ways. ठीक है? What if we have to find last 2 days that we have not discussed yet? We'll do it. आगे बढ़ते हैं. First we will LCM. हम last 2 days वाली बात को बाद में करेंगे. First we are going to the next topic, which is LCM and HCF. Yes. First we are discussing the LCM and HCF, and again we will see how remainders are connected with this. ठीक है? Last 2 days I have left so far. We will deal with it later. ठीक है? Right, previous things you have done. Now come here. Now introduction to this LCM and HCF. So LCM, I'm sure that you are familiar with the full form of these numbers. This is lowest or least common multiple, right? अभिषेक क्या हो गया भाई? आगे चलें? Should we start now? LCM, HCF? Yes. Don't get confused. No need to get confused. Okay, LCM and HCF we are talking about now. So LCM is lowest common multiple and this is highest common factor. In place of highest common factor, sometimes we use the term GCD also, that is greatest common divisor. That is same thing. Okay, now what do they mean? Say if I'm having an example, let's say there are 2 persons, a boy and a girl. Let's say this is a boy and this is a girl. Boy weighs say 72 kilogram and the weight of girl is let's say 60 kilogram. ठीक है? That's the weight, 72 kilogram and 60 kilogram. And now, खुशी जी क्या पूछ रही हैं? Why 66 mod 4? Why 4? अरे बाबा कितनी बार तो बात की खुशी, यूनिट डिजिट्स का साइक्लिसिटी और रिपीटिशन happens after every 4th power. That's why. यस साइक्लिसिटी, थैंक यू, थैंक्स गुंजन. हाँ, GCD क्या है? लेट मी राइट द फुल फॉर्म. ग्रेटेस्ट कॉमन डिवाइजर. सो समटाइम्स these terms are used interchangeably. Greatest common divisor. So now greatest means same, highest, common is common, divisor means factor, highest common factor, the same thing. Okay, come back here. So that's the situation now. There's a boy who weighs 72 kilogram and there's a girl who weighs 60 kilogram, and I want to weigh them. I need to weigh them by using a two-pan balance. एक तरफ इनमें से एक person को बिठा लेंगे, दूसरी तरफ जो है we are going to use weighing blocks. And now we are having n of weighing blocks of same size. इंटीग्रल किलोग्राम्स, ठीक है, सेम किलोग्राम वाले बहुत सारे वेइंग ब्लॉक्स हमारे पास हैं. सो टेल मी व्हाट इज द स्मॉलेस्ट वेइंग ब्लॉक, स्मॉलेस्ट इंटीग्रल वेइंग ब्लॉक व्हिच कैन बी यूज्ड फॉर बोथ ऑफ देम. दे बोथ आर टू बी वेड इंडिविजुअली. इसको अलग से वे करना है, उसको अलग से वे करना है, बट द वेइंग ब्लॉक्स जो हैं वी आर हैविंग ऑल आइडेंटिकल वेइंग ब्लॉक्स. तो स्मॉलेस्ट कितने कितने किलोग्राम का? स्मॉलेस्ट आई एम आस्किंग, नॉट हाईएस्ट. यू राइट इन डायरेक्टली 12. अरे स्मॉलेस्ट आई एम आस्किंग, स्मॉलेस्ट हाउ मेनी किलोग्राम वेइंग ब्लॉक विल वर्क? हाँ, थैंक यू सत्यम, थैंक यू. बाकी लोग क्वेश्चन सुने बिना ही आंसर दे रहे हैं. आई एम आस्किंग फॉर द स्मॉलेस्ट. 2 से कम 1 भी होगा ना. सो 1 किलोग्राम वाले अगर वेइंग ब्लॉक्स होंगे, सो दिस बॉय कैन आल्सो बी वेड एंड दिस गर्ल कैन आल्सो बी वेड, राइट? आफ्टर 1 किलोग्राम 2 किलोग्राम विल आल्सो वर्क, राइट? 2 किलोग्राम वाले वेइंग ब्लॉक्स होंगे, देन आल्सो बाय यूजिंग दोस 2 किलोग्राम वेइंग ब्लॉक्स आई कैन वे दिस बॉय एज वेल एज दिस गर्ल, है ना? आफ्टर दैट विल 3 किलोग्राम वेइंग ब्लॉक्स विल वर्क? यस, 3 किलोग्राम वालों से भी हो जाएगा ना. हाउ वी आर चेकिंग 3 किलोग्राम विल वर्क और नॉट? How are you sure 3 kilogram will work? 3 kilogram वालों से इस y को वे कर सकते हैं क्या? Yes, 72 is divisible by 3, or 3 is a factor of 72, right? 3 is a factor of 72, and 3 is also a factor of 60, right? So basically we are writing common factors. Thank you Samriddhi for using that term. So these are all common factors that we are writing. So after 3, 4 kilogram will also work, but 5 kilogram will not work, right? 5 kilogram will not work because 5 will divide 60. 5 is a factor of 60, but 5 is not a factor of 72, isn't it? Right, so 5 will not work. So after 4 kilogram, 6 kilogram is the next weighing block which can work. So by using 6 kilogram, I can weigh the 72 kilogram person as well as 60 kilogram person, because 6 is again a common factor of the two numbers. Okay, what is the next common factor? 7 is not 8, is not 9. Divide this number, but do not divide that. 10 is also not common factor. Then 11 doesn't. 12 works, right? After that, 12 kilogram works. What is the highest weighing block now which can divide both of them? It's 12 only, right? ठीक है ना? So these were all common factors, and the highest among them is known as now HCF or GCD, the highest common factor or the greatest common divisor, the greatest number which divides both the values or whatever number of values may be there. ठीक है ना? That was the meaning of this highest common factor. So we can understand how to calculate these values, but if we do not understand its meaning, then it becomes quite a difficult job. It's of no use if you do not understand what does it mean. So 12 kilogram, here 12 is the highest common factor, highest number, greatest number, which divides 60 as well as 72. How do we know it is highest? How can we be sure it is highest? Let's check. If I divide this number 60 by 12, so this can be written as 12 times 5, right? This is 12 times 5. ठीक है ना? And if I divide this 72 by 12, so I'm going to get this is 12 times 6. Fine. Now 12 was their common factor, that's fine. But is there any common factor in 6 and 5 greater than 1? No. So 6 and 5 are co-prime numbers. Their highest common factor is 1. They are not having any common factor greater than 1. So that confirms that 12 is the highest common factor. Alright? From here again we can understand very important thing that when we find HCF of two numbers, let me write here. If there are two numbers A and B, if their HCF, highest common factor, is let's say H, that means both the numbers are multiple of H, right? Both the numbers are multiple of H. So let me write A equals to H times X and B equals H times Y. Fine. Now what we have seen that if H is their highest common factor, then these numbers X and Y, so what kind of numbers are they? They are co-prime numbers. They do not have any common factor. In other words, highest common factor of X and Y will be 1. Fine. यहाँ तक की बात I hope clear है? Right. So we have understood the meaning of HCF, and if we know the HCF of two numbers, then the HCF, both the numbers are multiple of that HCF. They can be written like this: HX or HY, and where X and Y are co-prime, that their highest common factor is 1. Fine. Now the next thing, what about this LCM? इस LCM का क्या meaning है? Let's try to understand this also. Let me create some space first. इस part को साफ कर देते हैं. Let's change our storyline now. I'm keeping the same numbers, but I'm changing the storyline. Say there are two persons who are running on a circular track. ठीक है, ऐसा मान लेते हैं. There are two persons who are running on a circular track, person A and person B. They are running on a circular track in the clockwise direction, same direction. Okay? Let's try to understand the situation now. So they are running on a circular track, and A completes the round in exactly 72 seconds. And B completes one round in 60 seconds. B is the slower one. So B takes, B is the faster one, sorry. B is the faster one. So B takes 60 seconds to cover one round. Okay? Okay, so now question is, at the beginning, they are starting at same time. So at the starting, they check their clocks, and in the clocks, they started the stopwatch, and it started at 00. So both clocks were showing 0, right? Now tell me, when for the first time, A will reach here, the starting point again, what will be the time shown in A's watch? A की watch में क्या time दिखाई देगा? It takes 72 seconds to complete one round, and in the beginning, the stopwatch was set at 0 for both of them. So when A reached here for the first time, his stopwatch will show 72 seconds, right? After that, when he reached here for the second time, then, if I'm talking in terms of seconds only, so after 72, it will show 144, isn't it? Then again, 72 will be added to it. How much it is going to be? 216. Then more 72 will be added, that is 288. Then more 72 to be added, 360, and so on. Basically, all these are multiple of 72, isn't it? All these are multiple of 72. Fine. So these are the timings at which A is reaching at the starting point after every next round. Now let's check the same thing for B. So B, when he reaches at the starting point for the first time, so time in his stopwatch would be 60 seconds, right? It will be 60 seconds. And next time when B reaches here, the time will be 120. So same way as we did earlier, that was multiple of 72, and this time it is to be multiple of 60. So 60, 120, 180, 240, 300, like that. ठीक है ना? So is it possible that they reach the starting point here, when they reach their starting point, and they're having same time in their watch? When it will happen? When it will happen? A was reaching here when the time was multiple of 72. B was reaching in the starting position when the time in his stopwatch was multiple of 60. So when it will happen that both of them reach together? Man, if you're writing also 360, कैसे पता लगा? Let's say next number if I see, that will be 360 ही होने वाला है. That's right. And 360 is in both the patterns here. So we are looking for that number now, which is multiple of 72 as well as multiple of 60, right? Right? It is multiple of 72 as well as multiple of 60, which is basically common multiple. And this is the smallest or lowest or least common multiple. In short, we call it LCM. Right? Understood? So basically, as I said earlier, I'm repeating same thing. We can understand how to calculate LCM, how to calculate HCF, but what happens with most of the students, they do not understand that what is to be applied. क्योंकि question में directly लिखा नहीं होता many of the times, it is not mentioned in the question. As in this case, it was not mentioned clearly कि LCM निकालना है या HCF निकालना है. Right? So we should understand the situation and why we are calculating LCM or why we are calculating HCF. That is very important thing. Okay, some of you were saying कि इससे पहले तो कोई common नहीं आए. In case of highest common factor, we were seeing many common factors. Now tell me, is 360 second is the only time after which they are going to be together here? इसके बाद next time कब होगा? What will be the next time? What will be the next time when they are going to be here together? Yes, 720 seconds, wonderful. So basically now this least common multiple was the smallest, lowest common multiple, and now this is not the only common multiple. They are going to be all multiples of it. That means after 360 seconds, when the total time taken is 720 seconds, basically all multiples of 360. They're all common multiples. ठीक है ना? So LCM is basically the smallest number which is multiple of all the given numbers. Right? I repeat, LCM is the smallest number. This is 360 here is the smallest number which is multiple of both the given numbers. Now this 360 is not the only common multiple. All multiples of 360 will be the common multiples. कुसुम जी पूछ रही हैं यहां एलसीएम लेने का क्या मतलब होगा? मैं नहीं बोल रहा हूं एलसीएम लो. मैंने पूछा था, माय क्वेश्चन वाज कि ए व्हेन रीचेस द स्टार्टिंग पॉइंट टाइम्स आर मल्टीपल ऑफ 72. यू हैव टोल्ड मी 72, 144, 216 एंड सो ऑन. ठीक है, दीस आर ऑल मल्टीपल्स ऑफ 72. एंड व्हेन बी इज रीचिंग एट स्टार्टिंग पोजीशन, सो टाइम टेकन, टाइम इन द स्टॉपवॉच, दे आर ऑल मल्टीपल्स ऑफ 60, 60, then 120, then 180, then 240 and so on. So my question was, when they will reach here together, will that situation ever happen? So yes, they are going to happen when the time is multiple of 72 as well as 60, right? It should be multiple of both. So multiple of both means common multiple, and we have found that value also, that is 360. So this is the common multiple and this is the lowest common multiple, which in short is written as LCM. ठीक है? They may collide or may not, don't worry. But the point was how to find that value and how to understand when it is LCM and when it is HCF and why. ठीक है? Let's move further. Now we'll understand how to calculate LCM and HCF. Rishikesh is saying something. Time will same now because circular distance is same. Yes, exactly. We are assuming that they are traveling with constant speed and they are taking same time. Okay, let's move further. How to calculate now LCM and HCF? So one way is to calculate an LCM and HCF is by using prime factorization. This is the basic way. If we talk about the same numbers 60 and 72, so this is the normal way we have been doing in our schools. So जिनको याद नहीं है एक बार फिर से समझ लीजिए. So we can directly find their common factors like this, 60 and 72. We can write them together. So which number divides both of them? We are going to write here. So Although if you can see a large number directly dividing them, you can write that. Otherwise, you can start with the smallest prime numbers which divide. So 2 divides both of them. So 2 divides 60. So the quotient is 30. And when 2 divides 72, quotient is 36. Again, both the numbers are divisible by 2. So it is 15 and this is 18. Right? So now both the numbers are not divisible by 2 anymore. Now the next common divisor which divides both of them is 3. So let's divide by 3. So 3 5s are 15 and 3 6s are 18. Now 5 and 6, they are not having any common factor, right? They are not divisible by any common number greater than 1. So that's it, we are done. So all these three numbers, they are the common factors, right? So the highest common factor is basically product of these numbers, 2 into 2 into 3, that is 12. Okay, that we have already calculated also in some other ways. Now we are doing by this method. This is a school method which we have done in our schools. I think almost all of you must have done this. And now how we can find LCM? So for LCM, I need to multiply all these numbers and with these two numbers as well. So this 2 into 2 into 3 multiplied with 5 and 6 also. So this 12 basically multiplied with this 5 and 6 also. So that is 6 5 are 30, 30 into 12, that is 360. Right? So this is one of the ways we can find the common this common division method or common factorization we can do. And the other way is that which is more important for the time being, for right now, is doing the prime factorization individually. Let's see that also. So what is the prime factorization of 60? Please write in comments first. What is the prime factorization of 60? Somebody has written, I think Mohit, 2 into 2. Achha, you are writing LCM and HCF. What is prime factorization of 60? This is 2 square into 3 into 5, right? 4 into 3, 12, 12 into 5, 60. Right? This is 2 square into 3 into 5. And what about 72? This is 2 power 3 into 3 power 2. Is it fine? Right. Now by seeing the prime factorization, how I can find HCF and LCM? See, so for HCF, I'm looking for the highest common factor. So I need to consider only those prime numbers which are present in all the given numbers. So here 2 and 3 are the only prime numbers which are available in both the numbers. 5 is not there in the number 72, right? So 5 will not be included in HCF. So the HCF will include only 2 and 3 as the prime numbers. Now what is the prime number power 2 is to be taken? So for this common prime numbers 2 and 3, I need to see the lower of the powers. So for powers of 2, it is power 2 here and this is 3. So which one is lower? Which is the common, which is the highest power, which is common in both cases? It's 2 power 2. So basically the smaller power is to be taken, to 2 square, and same way in powers of 3, here it is 3 power 1 and this is 3 power 2. So 1 is smaller again. So this is 2 square into 3 power 1, that is 12. Chicken, na? So basically this is the largest number which is contained in both the numbers, it will divide them. And same way while calculating LCM, so we need to consider all the prime numbers because our number, this LCM, is multiple of 60 as well as 72. Because it is multiple of 60, so it will contain all the prime numbers with all powers. And it is multiple of 72, so it will contain all the prime numbers with all their powers. So this is 2 into 3 into 5. And this time we need to take the higher powers of the prime numbers. So 2 power 3, 3 power 2, and 5 power 1. So that is 8 into 9, 72, 72 into 5 is 360. Okay, so these are the basic ways to how to calculate this. Okay, Ram is asking LCM of higher powers. That's not a difficult thing. See now, if there's a large number, I'm writing that. Till this point it is clear, I hope. Okay, there are many properties regarding HCF and LCM, so we are going to discuss after this. So first, let's take some more examples so that we are clear about how to calculate LCM and HCF. I'm erasing this, I'm giving you more question now. Say, there's a number A, say 2 power 17 multiplied with 4 power 12 multiplied with 5 power 19, and there's another number B which is say 2 power 41 multiplied with 3 power 13 multiplied with 5 power 7. Okay? Please calculate HCF and LCM. First tell me the value of HCF of these two numbers. What is the value of HCF of these two numbers? I think it is faster. इसमें देर लगने वाला काम क्या है? These are faster only. First tell me HCF. HCF, I think Kapil has written 2 power 17, 5 power 7. Okay, that's wrong answer, Kapil. Prasoon has written 2 power 41. Not correct, Prasoon. HCF is not 2 power 41. Ayush 2 power 17, 5 power 7 is not correct. Ellen Rose has written 2 power 41, 5 power 7. Wonderful. Excellent, Ellen. Bhaiyon bhainon, you have been trapped. Harsh Gupta, that's perfect. Yes, good. Meghna, Bhumika Rao, Vansh. Good. See, this is not the prime factorization. This is 4 raised to power 12. Yes, 4 is not prime number. So first I need to write this number A in its prime factorized form. So this is actually 2 raised to power 17 power here and 24 power here, right? This 4 is 2 square actually. So 2 raised to power 24 it is. So 24 and 17 makes it 41. So 2 raised to power 41 multiplied with 5 raised to power 19. So that is the prime factorization of number A, right? And for number B, This 2, 3, 5 are different prime numbers, so this is prime factorization only. Now you need to look for these two numbers. Now tell me the answer. Yes, now it is of course right. So HCF is 2 raised to power 41 multiplied with 5 raised to power 7. We need to just consider the common prime numbers and with the lower powers. This is 41, this is also 41, so 41 will be here, and 5 power 7 and it's 19, so 7 will be taken because lower power is to be considered. 3 is not there, so that is not common, right? That is HCF. Now what about LCM? LCM कितना आएगा? Anirudh has written 2 power 41, 5 power 19 and 3 power 13. Yes, perfectly fine. So we need to take all the prime numbers with the higher powers available. That is 2 power 41 multiplied with 3 power 13 multiplied with 5 raised to power 19. Higher powers to be taken. Fine. Okay, so we have understood how to calculate HCF and LCM. In the previous slide, we understood what is the meaning of HCF, what is the meaning of LCM, and now we have understood how to calculate HCF and LCM by using the prime factorization of the numbers. And before that, we also discussed how we can find the value by using that common division method. ठीक है, आगे बढ़ते हैं. So how LCM and HCF are used in many remainder questions also. Power लिखना is trouble, Vijay. कोई बात नहीं, अभी if you have decided to go for CAT or any MBA, good MBA college, तो इतनी trouble तो लेनी पड़ेगी भाई. Let's move further. Okay, there are some important concepts for LCM and HCF. So this we were talking about in the beginning. For two natural numbers x and y, where x is h into a and y is h into b, a and b are co-prime, and h is their highest common factor. Right? As we said earlier, if h is the highest common factor, then remaining terms a and b they must be co-prime. That means they are not having any common factor. If h is their HCF, right? So what about the LCM? So if I'm taking LCM of x and y, it is going to be h into a into b. See, as we just discussed in the last slide, when we are taking LCM, so we need to take all the prime numbers with all their powers. So h is the common factor, so LCM जब लेंगे, तो LCM में h तो आना ही है, right? So it will be taken once. Now this a and b do not have any common factor, so both are to be considered. That is h into a into b. So that's how it becomes LCM, as written here, right? So HCF was h and LCM is HAB. Now very important thing we can understand from here, that product of the two numbers were HA and HB. So HA multiplied with HB becomes equal to the product of LCM and HCF. LCM was HAB and HCF was H. So that is this term in the box is very important result. So many times it is to be used. So HA was the value of X, HB was the value of Y, and H was their highest common factor, and LCM was HAB. So this product of the two numbers X into Y, this X into Y comes out to be equal to their HCF into LCM, right? So for two numbers, see this property is only valid for two numbers. ठीक है? Remjim is asking product कहाँ काम आएगा? Product of two numbers कहाँ काम आएगा? In some questions you may be asked about that. Sometimes it may be given. Sometimes we have to calculate that. ठीक है ना? हाँ, example अभी करते हैं. अभी example अभी हम करते हैं. जब LCM HCF given हो and one number given हो. Exactly, Harsh. Yes, that's true. See, there are four variables now: X, Y, HCF and LCM. तो इनमें से कोई तीन चीजें आपको given है, then you can find the fourth one. Right? Yes, example I'm giving. Let's move to next slide. यहाँ पे कुछ और है क्या? It can be noticed that product is equal to this. Yes, we have done that. And LCM is always multiple of HCF. That is also important thing. This LCM is always multiple of the HCF. ठीक है ना? That is also very important term. इसको भूलना नहीं है. This last part. This LCM is always multiple of HCF. We have just seen HCF H. तो LCM HAB. Of course, LCM is to be multiple of HCF. So sometimes if you find such values जिसमें LCM HCF का multiple नहीं आ रहा, तो that is not possible. Okay, let's see some questions. Here it is. Please try to answer. Some are writing A 196 and some of you are writing D. It is data inconsistent. So I'm giving you another chance for all of you, to all of you. Please recheck your answers and correct it if required. Okay, देखते हैं. Now most of you are answering 196 on my screen, but in between still. Some of you are writing A also. Let's see here. LCM and HCF are given, that is 280 and 63. And one of the number is also given, 90. Then the other number is. So if you directly jump to that result which we just saw, that two numbers X multiplied by Y equals to the product of their LCM and HCF. If you plug in these values directly here without checking, without thinking, without giving it a second thought, you can find the answer. So one of the number is 90. So let's say Y is 90. So X times 90 equals to the product of LCM and HCF. So LCM looks like 280. and HCF is given 63, and you if simplify this, you will get the value of X as 196, right? Lekin, don't jump into this. We just see in the last slide, we just saw that this LCM must be multiple of HCF. And moreover, if you don't remember that, कम से कम इतना तो देखना ही होगा ना. The one of the number is 90. Can 63 divide 90 completely? 63 is not a factor of 90, right? How it can be highest common factor? This data is inconsistent. Fine. Yes, 90 cannot have HCF as 63. So basically, we should be very, very, what should I say, present while solving the question. We should not be absent-minded. Just remembering the formula and applying it will not work. Okay, let's move further. There's some important concepts. Let's see that. Now, these are all concepts which we are going to discuss now. They are related to how the questions in remainders, in the category of remainders, how questions use this LCM and HCF concepts. Okay? Now, let's see this one. तनिष्क बोल रहे हैं सर सॉल्व करके भी आंसर नहीं था ऑप्शन में. था भाई 196 था, आपकी कैलकुलेशन भी गड़बड़ है मतलब. तनिष्क यू आर नॉट डूइंग कैलकुलेशन करेक्टली. 196 आ जाएगा कैलकुलेशन करेंगे तो. Anyway, but that was not correct. That was inconsistent. Okay, see here now. Rajat is again asking something. क्यों भाई? Please explain once more. क्या Rajat, in that case, अरे बाबा देखो. Here it is given that HCF is 63. ठीक है ना? If HCF is 63, that means the numbers must be multiple of 63. Is it not? And now one of the number is given 90. Is 90 multiple of 63? Not. Data is wrong. ठीक है ना? And also this LCM has to be divisible by a multiple of 63, which is not. That's why this data was inconsistent. So we should not directly plug in the values in the formula and get the answer. That was wrong. Okay, we have to cover more concepts. You will practice many more questions in many other ways. So let's try to understand these concepts. Now there are 2-3 concepts which we have to cover. I don't want to go beyond the time. I wish to finish it in time. Although we started 5-10 minutes late because of technical glitches. Please focus here now. So this is an important concept. So if n is a positive integer which leaves remainder r each time when divided by x, y or z, these are different divisors, then n is of this format. If you do not understand any of the thing here, don't worry. Let's see the question. This question says, find the smallest number which leaves remainder 3 when divided by 4, 5 or 6. Try to answer this first, then we'll discuss. Try to answer this question. Find the smallest number which leaves the remainder 3 when divided by 4, 5 or 6. 4 से divide करने पे भी remainder 3, 5 से divide करने पे भी remainder 3 and 6 से divide करने पे भी remainder 3. What is the smallest such number? 63, 33. So far I have received 3-4 answers, 33, 63, and between I saw 123 as well. 123 as well. These are the different answers said by you. I am writing here. 15 कैसे आएगा अक्षय? ऐसे तुक्का नहीं मारना, फेंकना नहीं है कुछ भी. 15 is divisible by 5. How is it possible? Akash, wonderful. All of you have missed 3. 3 is the smallest number. Okay, now let's focus here. In CAT, we have many questions which are having options. Although there are some questions in which we have to write the answer, we have to type the answer, but still there are many questions in which options are there. So in this question, if options are there, so what I need to check? I just need to see when that number is divided by 4, I should get a remainder of 3. When the number is divided by 5, then also remainder should be 3. And with 6 also it should give remainder 3, right? So let's check these options also same way. If I divide, let's start with this 3 only. If I divide 3 by 4, 5 or 6, in each case, it is going to be 3 only. That satisfies, that's the smallest one. But what will be the next such number? Will 33 satisfy? Let's see. If I divide 33 by 4, क्या remainder 3 आएगा क्या? No, remainder will be 1. So this does not satisfy. Right? This number does not satisfy. Let's check 63. If I divide 63 by 4, then 3 is the remainder. Right? 60 is divisible, 3 is the remainder. If I divide it by 5, again 3 is the remainder. If I divide it by 6, again 60 is divisible, 3 is the remainder. So this also works. Right? And same way if I check 123, that also works. But question was asking about the smallest number. Right? So of course smallest number here is 3. So basically now how it is related with LCM or HCF कैसे करेंगे? Some of you have written in comments. Let's see here. 3 कैसे work किया? Good question Shubham. Let's see here. So it is just like clubbing the remainders which we have done in the previous sessions also. कि now we know there is a number which when divided by 4 gives remainder 3. 5 से divide करने पे भी remainder 3 and 6 से divide करने पे भी remainder 3. We need to club these 3 remainders. That's it. 33 does not satisfy, na? 33 ko if you will divide by 4, if you divide 33 by 4, so 4 8 is 32, 1 will be the remainder, na? So it satisfies the condition of 5 and 6. 5 से divide करूंगा तो 3 आएगा, 6 से divide करूंगा तो भी 3 remainder आएगा, but it does not satisfy the condition with 4. That's why 33 is not correct. ठीक है? Come back here. So basically, I know that when this number is divided by 4 or 5 or 6, in all cases we are getting the remainder 3, right? So what this condition is, either we can make equations. Yes, it is 3 mod 4, 3 mod 5, 3 mod 3. Wonderful. Somebody has written here. So How does 3 satisfy? I'm confused. कैसी बातें कर रही हैं एंजेला जी? एंजेला आप बताएं, अगर 3 को 4 से डिवाइड करेंगे, what will be the remainder? It's 3. Yes, Saurabh, you have written the correct equations. We can frame the equation and we can simplify it. But very important thing here is to see that, let me write it another way. So this number n is of the form 4a plus 3. Right? I can write it like this also. Right? I can write it like this also. This number is 4a plus 3. 4 से divide करने पे 3 remainder आ रहा है. Alright? And same way, can I say here that n minus 3 is divisible by 4 or is multiple of 4? Can I say it like this? Please understand here. हाँ, शादी में जाना है, शादी का खाना खाना है, रुक जाओ, मुझे भी जाना है, शुभम, we'll finish the class. We'll finish the class, after that you can go. So n is 4a plus 3, so can I say n minus 3 is multiple of 4? Right? Exactly same way, this n is equal to 5b plus 3 as well. N is 5b plus 3 as well. So that means this n minus 3 is also multiple of 5. And similarly, n minus 3 is also multiple of 6. Because 6 से भी remainder 3 ही मिल रहा है. Is this point clear to everyone? So from here, we got to know that this n minus 3 is multiple of 4 as well as 5 as well as 6. Right? This n minus 3 is multiple of 4 as well as 5 as well as 6. So that means, can we say n minus 3 is common multiple of 4, 5 and 6? Yes. That's how this LCM comes into the picture here. So basically answer here would be like this, that n minus 3 should be a multiple of LCM of 4, 5 and 6. Which means n must be of the form k times LCM of 4, 5, 6 plus 3, and that's what is written here. ठीक है? Although while working with numbers, we didn't go about the whole mathematics and whole equation format, but we should understand this format as well. What is happening? So basically, whenever we are having same remainder, as in this case, what we can do, we can say that n minus 3 is multiple of 4, n minus 3 is multiple of 5, and n minus 3 is multiple of 6, which means this n minus 3 is multiple of all these three numbers. N minus 3 is common multiple of LCM, common multiple of them. So this is multiple of the LCM. So from here we get the value of n as it's multiple of the LCM of 4, 5, 6. Achha, what is the LCM of 4, 5, 6? Can you write? What is the LCM of 4, 5 and 6? Tell me, what is the LCM of 4, 5 and 6? We'll calculate the answer then. What is the LCM of 4, 5 and 6? It is 60, right? So if I put the value 60, so it comes out to be 60k plus 3. Right? So n is a number of this form, 60k plus 3. So as you have found, if I put k equals to 1, so 63 is also possible. If I put k equals to 123 is also possible. But if I put k equals 0, then 3 is the smallest number, right? So 3 was the answer for this question. Got it? So basically, whenever we are having equal remainders, in that case, the process becomes very easy. Ishani, I have not used any number method or equation method. What I'm seeing here is that part only, as I said, that n minus 3, n minus 3, n minus 3 is multiple of each of 4, 5 and 6. So it must be multiple of 4, 5, 6. N minus 3 must be multiple of their common multiples. That's what we have done. So I have not used any equation method or number method. We're just understanding the basic concept that because the remainder is same in each case, so I cannot say n is multiple of 4. It is not. But n minus 3 is multiple of 4. Right? Exactly same way, n minus 3 is multiple of 5 and n minus 3 is multiple of 6. Let's move further. There are some more things. What if remainders are not same? What if remainders are not same? In this case, remainders were same. It was quite easy. Basic thing. So what if remainders are not same? Let's see the next concept now. If n is a positive integer which leaves different remainders, R1, R2, R3, अलग-अलग remainders मिल रहे हैं. In that case, with the different divisors. But what is same thing here? The difference between the divisor and the remainders is same. X minus R1, Y minus R2 and so on. Then what to do? Let's again take the example here. So find the smallest number which when divided by 8, 9, 10 leaves remainder 3, 4 and 5. So मैं लिख देता हूँ. N is such a number which when divided by 8 gives remainder 3. When divided by 9 gives remainder 4. And when divided by 10 leaves a remainder of 5. So again, we are to club the remainders. So by how to club, we can make equations, so we can work with numbers. But the method of LCM which we just did in the last slide, let's try to apply it here. I'm writing them again in that format. So this n equals to multiple of 8 plus 3. Because it leaves a remainder of 3 when divided by 8, right? So 8a plus 3. And this is also of the form 9b plus 4. And 10c plus 5. In the last case, all these remainders were same. So what I said, n minus 3 is divisible by 8, like that. N minus 3 divisible by 9. But this time, remainders are different. So what to do now? Now, what is the important thing here? Durgesh, I can see the time. Don't worry. You're showing me the time. Just wait for 2-3 minutes. We will finish it. Actually, there's 1-2 more concepts. We will finish it. This is the last part for the day. Let's just cover it. So this is 8a plus 3, 9b plus 4, 10c plus 5. Now what we can see as written here, if you see 8 minus 3 is 5, right? The difference is 5. Same way 9 minus 4 is also 5. 10 minus 5 is also 5. The difference is same. Which means if I convert it in a negative remainder, can you tell me if a number is giving remainder 3 when divided by 8, what will be its negative remainder? What will be the negative remainder? If a number gives remainder 3 when divided by 8, what will be the negative remainder? Yes, -5. कैसे पता लगा? I just need to subtract the divisor from this. So 3 minus 5, 3 minus 8 will be -5. So it can be written as some 8a dash minus 5. Same way here also, what will be the negative remainder? 4 minus 9, that is again 9b dash minus 5 and 10c dash minus 5. Now it is exactly same as we did in the last case. Right? Now it is exactly same as we did in the last case. We have made all these remainders equal. So that means n plus 5 must be multiple of all of these values. Right? So basically in this case, n plus 5. This n plus 5 is multiple of 8 as well as 9 as well as 10. So n plus 5 is multiple of LCM of 8, 9, 10. Which means n must be multiple of LCM of 8, 9, 10 minus 5. Which is written here if you see. That's the result here. So if you want to remember the result, it's up to you. But I wish that you understand the basic concept. Now what is the LCM of 8, 9, 10? Can you write quickly? What is the LCM of 8, 9 and 10? It's 360, isn't it? It's 360. So 360k minus 5. So n is a number of the form 360k minus 5. Right? So now what will be the smallest value of n? Question was smallest number will satisfy this. So for smallest number, we need to take k equals to 1 and answer will be 355. Right? That's Koshani, that's perfectly fine. So 355 is smallest such number. In this case, we can't take k equals to 0 because number cannot be negative. Right? So 355 is answer to this question. I hope this is fine. So these are the important concepts. If we are having same remainders, we directly found the answer that LCM, multiple of LCM plus that remainder. In this case, again we have made it same remainder, but this time it is negative. So by using same method, so multiple of LCM minus that remainder. So this 355 is this part. So we'll stop here. So thank you all for being so patient to remain here till end. Thank you very much, and I will request all of you to please solve more and more questions to make the things clear. And wherever you find any doubt, you can certainly revise the whole class. And numbers में काफी सारी चीजें ऐसी हैं जो नई हमने सीखी हैं. Although LCM HCF is an old concept, you might be knowing it already. But still, number में काफी सारी चीजें हैं जो हमने नई सीखी हैं. So please revise again and solve questions. Thank you very much. So you can share your feedback if there is any concern, anything you liked. Is it all clear? हाँ, smallest number find out करना था. Yes, thanks Vidushi. थैंक यू एवरीवन. जिनको भूख लगी है खाना खा सकते हैं, शादी में भी जा सकते हैं, किसी को जाना था शायद. ओके गुंजन, पॉइंट नोटेड. थैंक यू सोनू, थैंक यू वैभव. गुड नाइट एवरीवन. अंकित, अरात्रिका. अर्थमेटिक कब से स्टार्ट होगा? नक्षत्र प्रताप जी पूछ रहे हैं. आफ्टर नंबर्स में आई थिंक 2-3 टॉपिक्स बाकी हैं अभी, तो मे बी 1 or 2 more classes in numbers topic and then we can move to arithmetic. थैंक यू सूर्य, थैंक यू रजत, शुक्रिया महेश्वर. Yes, Isha, apply all the things which you have learned in application class. Yes, thank you Vedanti. See, whenever you have any doubt in any concept, certainly clarify it. तुक्के मार के आंसर निकालने से सीखेंगे नहीं कुछ. LRDI class we are having now, I think day after tomorrow. Tomorrow there is no class, no live class. Day after tomorrow we'll be having our next DI class. Okay, फिर मिलेंगे. Thank you Ritank. थैंक यू शेख, सामा, अनुराग. अरे कुछ तो बोला मैं मिस कर गया. आरशी घोष, लास्ट वाला कॉन्सेप्ट. आरशी, इट इज स्टिल ऑन द स्क्रीन. आई विल रिकमेंड यू. आई हैव सेड व्हाटएवर आई हैड टू से. आई हैव सेड एवरीथिंग. जो मुझे बोलना था, आई हैव सेड एवरीथिंग. सो आई विल सर्टेनली रिकमेंड यू, सो यू कैन सी द लास्ट 5-10 minutes or 15 minutes रिकॉर्डिंग अगेन. इट विल बिकम मच क्लियर. हाँ, शवदीप इज आस्किंग 8a plus 3, 8a minus 5 कैसे हुआ? मैंने 3 में से एक और 8 निकाल लिया शोवेश. Sorry, Shawdeep, मैंने 3 में से एक और 8 निकाल लिया. 3 में से if I subtract 1 8, so it is going to be -5. Ramu is asking, LRDI sets explain properly. Some sets are data unable to understand. Yes, Ramu, you are correct. So when data is not understandable properly, in that case, it won't be possible to solve. So that's why we need to practice and we need to understand. We need to understand what is being given, how the questions are framed, how we are to answer. So it will take time. Don't worry. There will be all types of sets. भाइयों, LDRI का मजाक मत उड़ाओ. शफीउद्दीन, explain this one again. Which one, Shafiyuddin? Thank you, Shawdeep. Thank you, Vinny. What's this comment? Okay. Yes, Jitul. It was nice presence of all of you. Thanks to all of you. अंशिका, LRDI पार्ट में प्रॉब्लम है. प्रॉब्लम तो पूरे मैथ्स में ही है. मैथ्स का मतलब ये प्रॉब्लम सॉल्विंग. You know, this quant LRDI part is sometimes known as problem solving. There are a lot of problems and we have to solve them. So some of them will be able to solve and some may not be. It's okay. But keep on. Don't give up. That's the important thing. ठीक है ना? Don't give up. Okay, we shall end now, and we will meet next time, day after tomorrow, with DI. Mohammed Shafiuddin, you're asking last part of this question. Last part is same, beta. 8a plus 3 was 8a minus 5, remainder 3 is minus 5. In all cases, we are getting same remainder. So it is exactly same now as we did in the last case. So 9n plus 5 becomes multiple of 8, 9, 10. Ha, Ritik, that's a good thing. How did you find LCM so fast? Because I am using their prime factorization. I know that 8 is 2 cube, isn't it? And all other numbers, 9 is not having any power of 2, 10 is having only 1 power, so LCM will contain 2 cube, right? Now this is 3 square. 3 is not anywhere else, so 3 square is the highest power. So 3 square will also be there in the LCM. And other than that, only prime number remaining is 5. So 8, 9, 72, 72 into 5, that is 360. That's how I did it. And that's how we discussed also. So Shafiuddin, this was 9n plus 5 is multiple of 8, n plus 5 is also multiple of 9, also multiple of 10. That's how we wrote it. Exactly same way we did in the last case. I will take your leave now. Thank you.